Good morning and thank you for attending our One Spatial webinar today. My name's David Eagle and this session is called Tuning FME 2017 for Speedy Data Processing. We're going to look at a few hot tips for things that you can do to your processes to make them more performant, and we'll get straight into the detail. So these are the things that we're going to take a look at. We're going to have a look at some of the turbocharged formats that are entering FME. We're also going to look at parallel processing. This is something we've covered before on our webinars in the past, but I want to show you an application of how you can make parallel processing give you some real benefit. So that'll be a specific use case when it comes to reading and writing data in a more performant way than perhaps you've managed to so far. So they're the topics of the session. Just a very brief bit about One Spatial. We've been value-added resellers of the FME product now since 1999, so a good few years of capability there. We support all of the products, so that's FME Desktop, FME Server and FME Cloud, and we've got a number of people who use FME every day in our business, and some of those staff also have certifications, be they a certified FME professional or a certified trainer. We also have a dedicated support team, so if you buy your FME licenses from ourselves, you get technical support from us under your annual maintenance contract, so you can get in touch with us through support@onespatial.com. And we provide all of the services that you'd expect around the FME technology stack. So first technical review, really, first technical demo is around turbocharging our data and getting data into our FME processes more quickly than perhaps we have done in the past. The first thing I want to highlight then is a little prepared FME workspace that just shows you a little bit of this in action. So here's FME Workbench. This is FME 2017. It's the latest build that you can download at the moment from safe.com. What you can see here is a number of readers set up. These are effectively readers that have started to get some of this new turbo technology. It's internally referred to by SAFE as feature table capabilities, and I'm not going to go into that in too much more detail because we've covered it in previous webinars that I'll reference later on in the session. But first of all, you can see in the navigator window on the left hand side that there are 4 readers. So we have a CSV reader. This is a CSV reader that was added into the workspace in FME 2016. Basically the workspace was authored in FME 2016 and the reader was added in at that point. The workspace has then been opened up in FME 2017 and a new CSV reader has been added in. In FME 2017 you get the new CSV reader. So what we're highlighting here is that there are versions associated with readers. And they can be revised in some cases quite significantly, just like has happened here. There is a subtle increment in the name to suggest that this is slightly different. So this is the CSV Reader 2 here. Let me show you the way that this process runs. So I've got all the readers disabled apart from the top one. I'm just reading in data from a couple of CSV files. Here, and you can see that I'm just sending them to the logger, and there's a few 100,000 records piping their way through the workspace, and you can see that data trundling its way through. The logger is reporting the data as well, and it's still going. We're what, 28, 29, 30 seconds in. I'm actually going to stop it because I don't want to wait any longer. So let me just disable, so Control E on your keyboard will enable and disable I'm going to re-enable. This is the same data, same files. You can see that I have my path defined, so I can go and have a look at the ability to see which files. There's a couple of CSV files in there. So if I run this now, so we ran it for 33 seconds before and it didn't complete the read. If I rerun it, reading the same data using the second CSV reader, what I'm hoping for is the data to pile into the workspace much quicker, and you can see that there it is and it's done. So 2 million records read in 10 seconds instead of 700,000 read in 33 seconds previously. So the CSV reader has had a very significant overhaul for FME 2017, and it's one of the readers that has now got this extra speedy capability. One of the other ones that has this new capability is the brand new for FME 2017 MapInfo tab extended format. Now, MapInfo tab's extended format, it's a brand new format introduced by Pitney Bowes into MapInfo Professional and some of its products. In MapInfo Professional 15.2 is the version that it's introduced in. And it does a number of things. First of all, it allows you to create MapInfo tab files with a greater than 2 GB file size. So it breaks down that previous barrier to volume, because the MapInfo tab format is built on the old DBase format structure. The DBF file is the restricting part there. And it also allows you to do clever things with different character sets as well. So it's an interesting format. From an FME perspective, if I read in some MapInfo tab files, you can see I'm reading a couple of MapInfo tab files in here. 73,000 features, takes 5.5 seconds reading that data using the traditional MapInfo tab reader. One of the benefits, though, of this MapInfo extended format is that you can actually point it at a traditional non-extended MapInfo tab file and it'll just read it quicker. So it's a nice little hot tip if you hadn't realized. So 5.5 seconds to read the data previously with the old reader. The new reader takes 1.8 seconds. So you can consume the data into your process much quicker. And if the reading is where a lot of the effort goes in your process, then hopefully that bottleneck can be removed. Now, obviously, this is just a couple of formats that get this capability in FME 2017, but in time we're going to see this this capability ripple its way through a lot of the other formats to give us a much more performant way of getting data into and out of the format containers that we care about. So, turbocharging your readers, all well and good. What about using the full capability of your FME of the hardware that you've got your FME installed on? So let me just close down that old process and we'll get into a topic around threading. So this is effectively where you have, if you have a machine that has multiple cores, sometimes each of those cores can have more than one thread. That basically means that you can start executables on your machine and run more than one at a time. Processor utilization in FME, well, I mean, effectively, if you have more than one core, more than one processor on your machine, there's much more chance of FME being able to get a core to itself. You know, you might have Outlook running, you might have ArcGIS or MicroStation running, you might have FME running. Multiple cores means that those applications are going to get access to a core themselves. There's a few things. I mean, FME itself is it's not a multi-threaded application, and we'll get into that in a bit more detail in a moment. But in FME 2011, so looking back some time now, when you run a process, if you get part way through it and you need to free up your machine to do something else, you can actually hit the pause button. It's basically the run button becomes a pause button when a process is running. It'll hold it, it'll give you back your processor. It will not give you back the RAM that's being used, because data will be held in memory. Obviously, if that was given back to you, then your process would fail, because the data is no longer in memory. So you get a pause option to get your processor capability back. That's also handy actually to pause it in order to have a look at the log without it shooting past you all the time as your process is running, if you want to read something in more detail. But yeah, much more interestingly, you can actually get some transformers to use more than one thread. So as I say, FME is not multi-threaded itself, but some of the transformers, effectively the heavy lifters, can use more than one thread, and there's an increasing number of transformers that are getting this technology. Actually, the last two versions added in lots of additional transformers to have effectively this parallel processing level added to them. So, what is parallel processing level? Well, you can see that there's some options. There's obviously no parallelism. That's the default for a transformer that has this capability. You can turn it into minimal, moderate, aggressive, and extreme. Effectively, they all mean the following. So, we can see minimal. That's the number of cores that you have in your machine divided by 2. So I have an 8-core machine, so that would mean that I would run 4 processes at one time concurrently. There's moderate. That's the same number of cores that you've got. So in my 8-core machine, that would be 8, effectively 8 worker instances that got started. Aggressive and extreme are to be used advisably. What the issue is there is effectively you potentially are going to try and run more applications or more instances of FME than your machine can cope with. Really aggressive and extreme are used when you are making something like multiple web calls to perhaps an API, where you're not actually running something on your local machine. It's more of a sort of a web request approach. So typically you wouldn't really select any more than moderate. So under the bonnet, what actually happens? Well, you get to start multiple sub workers. So if you had a process, let's say you had zip code, postcode boundaries, and you wanted to dissolve the boundaries of all of the zip codes in a particular area, and you had lots of postcode sectors, the smallest boundary, and you wanted to know what the wider area was, you could do that by grouping by area. So if you had a postcode area that 50% of your postcodes had, and the other 50% were in another postcode area, you could set the group by to the postcode area and then effectively start 2 worker instances to do those jobs concurrently. And you can do that just having one workspace. So it's much simpler. So the key thing really, as you'll understand from that example, is that you need to, if you're going to use parallel processing, you have to have an attribute with which you can group by. So you have to have some categories assigned to your data to group them. So if you had 8 categories assigned to your data, you could have 8 processes where those individual records were grouped together in their collection and were operated on as one unit of data. The one thing to bear in mind is if you don't have already allocated categories, you can nominally allocate those using a pretty clever little transformer called the modulo counter. This allows you to assign a value to your data within a range. So if you set that to a range of, say, 4, you would have each feature that passed through it gets set to a value of 0, then 1, then 2, then 3, then 0, then 1, then 2, then 3. Assigning each feature to its own group. You can then use that modulo count attribute that gets created as your group by. There's a really useful article if you want to go and have a quick look at this article over here. Let me just grab that and bring that in. So you can see there's the knowledge article, article 1211 on parallel processing, written by Dimitri Barg. If you want to learn a little bit more about that capability, then it's worth going and have a look at that article on the Knowledge Center. There are also some parameters around parallel processing, and that's the kind of thing that we can start to play around with, I'll highlight shortly, because that's where we can get some benefit from some of the newer capabilities in FME with some of the newer transformers. So read and write order. What's the point of this? Why are we talking about it? Well, part of the reason is because I'm going to take read and write order, and I'm going to take parallel processing, and I'm going to couple the two together to get something new. The rules to bear in mind then when it comes to reader and writer order is that when readers are defined and listed in the navigator in your workspace, they read the data first into the workspace. So the first one at the top in the left hand side of the navigator, that's the first one that gets read, then the next one, then the next one. So if you have 3 readers, they get read in that order, and the data is read completely out of that reader before the next one starts. The same is true of the writers. The one that's listed first is the one that gets its data written to it to completion first. The second writer can't start physically writing to disk until the first writer has closed. So all of that data potentially gets held in memory, which means that it's very sensible to consider which writer is going to receive the most data and make sure it's listed first, so that you hold the least amount of content in memory. You read one data set at a time, and you write one data set at a time. This is something to be aware of in FME. It is also an issue that SAFE are well aware of, that FME has had for some time. It's not necessarily the best thing in terms of performance to operate like this. SAFE are well aware of it. It's quite difficult to resolve, but they're working on it actively. However, I'm going to give you a hot tip to get around the challenge. But it's worth, if you're looking at performance of your processes, going and having a look at these 2 articles. So the Evangelist, FME Evangelist article there listed, so that's a blog article talking about the order of your writers. Here it is. So it's the first writer article. Very worth going and taking a look at in a bit of detail. There's also an article rather than a blog that goes into the writer order and FME performance. This is written by Ryan Craig. So good bit of detail there around performance. Heartily recommend you going and having a look at that one. So let's try and take these capabilities and see what we can do. I mean, readers and writers have this sort of order issue, but what about the newer transformers, the feature readers and feature writers? Well, they do have the same issue. They write one thing at a time, or they read one thing at a time. But the benefit to these new transformers is that they can be adapted. You can customize them, turn them into custom transformers. The feature reader and feature writer, one of the biggest benefits is that you can easily do something before them and something after them without actually having to have multiple workspaces. So you could write your data out, and then you could have an emailer that goes and reads the data back from disk or attaches it to an email and sends it off to somebody. With the feature reader, you can define exactly what you want to read from where before you physically go and read it. So it saves you a lot of effort and potentially processing time through not reading too much data. So if we turn these into custom transformers to try and get around this single-threaded approach to reading, we can bring multitasking in and start try and rescue the situation, or making the read and the write more performant by throwing in a bit of extra capability here. So let's go and have a look at what we mean. So I'm just going to start up a workspace. Now this is sort of a cut of a slightly larger workspace that reads Inspire index polygons. These are land registry boundaries that are available on data.gov.uk, and they're published and available for us to go and download. So I've actually used an XML reader that goes and reads a catalog of all of the files that are available to go and download. And this first portion of the workspace actually just goes and preps the path to the zip file that I want to go and read in, and then the feature reader does the work. The feature reader receives the path to download, so there you go, the download path. It reads in a GML file that's inside the zip file. So the workspace handles downloading the zip file, unpacking it, reading the GML from within, and then processing it through to the rest of the workspace. It removes bounding boxes around polygons and tidies up the attribution. And if I just kick this off, you can actually ignore the top section. That's just in case their service went down for any reason. I've got that available. We'll soon find out when I click run whether that's an issue or not. So if we just run it, there we go. So it's going to read all the URLs, and what you'll see here is that it's read two of them, and it's sending the next one, and it should read another batch of data in a moment. And we'll just zoom in on this section of the workspace to see that happening. So you can see here that the feature reader is reading the data in lumps, one zip file at a time. Okay, so it's just prepping the next one, and you see the URL in the log there, and there's the next one fired through. So if I ran this to completion, there's 348 files that it could potentially download and read. Obviously don't want to do that. I've actually got a sampler here that runs and fishes out the first 10. I've run this for nearly 40 seconds now. I'm just going to stop it. There's about 52,000 polygons been read through there. What it would be useful to do is go and take that feature reader and turn it into a concurrent feature reader. You can see I've got one tucked away down here. Let's first of all see what this does, and then we'll go and see how we can make it. So I'm just going to replace this workflow with this transformer here. It's called the concurrent feature reader, and I'm just going to enable it. And you can see inside this transformer we have a parallel processing capability, and it's going to parallel process by region. Now the region is the name of the zip file. So this is what I said earlier on about having to group by. I'm grouping on the file, and then I'm going to go and read from that file, and I'm actually going to set it to minimal. and go and do that read. Okay, so minimal means that I'm going to read 4 zip files at a time. So if I just move this over here, I'm going to make sure that link is disabled and rerun this and hit go. So you can see those timings on the annotation there, but there's 4 files that are just getting read at the same time. They're individually getting read, and we should see a lot more data fire out of here. The other thing I can do for you is open the task manager and bring that in so you can see what's going on here. So you should be able to see multiple FME.exes starting here. There's another one popping up. If I sort perhaps by maybe by name. There we go. There they all are. Okay, so there's all the executables firing up and running. There are a few others in here. These are my FME server engines, so they can be ignored. So you can see there's multiple instances, worker instances running. And you can see that we've got lots of data flooding through the process with this multiple concurrent read that's going on. The thing that actually I have done incorrectly here, of course, because it's a demo, is that I should be doing that. I want to completely bypass this this feature reader. So let's go and rerun that, and that will make a lot more sense now. Just want to take that that original feature reader out of the equation. I was reading the zip files twice, which is a little bit silly. But there we go. That should work more efficiently now. So this concurrent feature reader is making its way and doing the read. While that's happening, I'm going to go over to the details of this transformer, and you can see it is literally just a feature reader, and the feature reader has got inside it some parallel processing parameters that have been switched on, and that's what makes them available on the front page here. So you can take any transformer that doesn't have parallel processing capabilities at the moment, and you can give them parallel processing by just adding in turning them into a custom transformer. So let's go and have a look at how to do this. I'm going to let this run actually just to see if it completes. It should do. It's not far off. 200,000 odd made its way through, so should rattle through pretty quickly and give us a result. What I've found in testing, as you can see, is actually there's very little benefit in going much beyond minimal, frankly. The difference is 3 minutes. You know, you're cutting your time by about a third to basically read 4 times as much as you are with the single thread. Move it up to 8 times and it's no better really. So 1 minute 47 in this run. Sometimes environmental issues like internet access and speed is going to make a difference. That maybe made a difference here to my run previously, but that concurrent read just came in significantly quicker than if I'd have waited to let it run. It probably would have run for very nearly 4 minutes based on that test. So let's go and set this up. So if I had this process here, how do I go and turn this into a custom transformer? Well, I can right click on it and I can create a custom transformer. I'm going to call it the concurrent, if I click in the right place, concurrent feature reader, and there we go, I've got it. And you can see that over here on the main tab I've got the transformer. It doesn't look very pretty, so let's make it look a little bit prettier. So we'll go for input, and we've got output, and we've got our very own rejected port. If we go back to here, now it looks a little bit prettier. You can see that we've got that concurrent feature reader defined. And then in order to make it concurrent, we've got to go in and publish and create a user parameter on the parallel processing capability. And that by default publishes this parallel process by. Now you can go in and edit that if you want to. If you go and edit the user parameter definition, and then you could say that you want to call that group by, just so it's consistent with the normal setup there. Will it let me do it? Yeah, it's applied that there, parallel processing and group by. And now I've got the option to have that set up. And now I've got my custom transformer. So I can now read multiple data sets at the same time. Hopefully that's a useful hot tip, but it doesn't stop there, because if I just close this down, you can do it at the other end as well. So there is now a feature writer transformer. Let's just bring this in. The same is true here. I've got some of that output data, the index polygons, stored in a format here. In this case, I've put it into FME's internal format, FME feature store. Style the data up and write it out. So if I just pop in here the output directory, I'll just bring that over so you can see that in a moment. And then if I run this and start it writing, what you can see is I've set it up to write out some KML files, and they should start to make their way out here in a moment. So go to the feature writer. You can see inside the feature writer we've got origin file index polys is what the name of the file is going to be called, the layer is going to be called inside the KML file, and then we've got origin file.kmz is the file name itself, and then this will rattle through and create us some output shortly, and you can see that that's taking some time to produce the required KML. So there we go. It's just started to rattle some out. There's the R's are silly, made its way right into the file system. So it's taking a little while to do that. There's the Tower Hamlets one, and then there'll be another one in a second. Okay, so I'm just going to stop this process. I'm going to go to that output. I'm just going to delete that. So that ran for 66 seconds or so. So I'll just switch over these links. It's the same deal. It's the concurrent writer. It's just exactly the same process, but it's a feature writer inside there now. So we run this again, and we should get to see concurrent writing. There we go. There's the R's are silly straight away. There's the City of London. We should get a lump of these in a moment, because the files have got a little bit more data in them, so it's taking a while to pull that through and write it out, but we should get those in a sec. And you can see with the timings on the in the annotation there that there's a good few seconds knocked off this, very nearly half the runtime when you go to a 4 times process. So when you've got data that needs to be produced quickly, making feature readers and writers benefit from this multi-threading capability. could mean that it's another reason to start considering feature readers and writers in your processes instead of readers and writers in quite a lot of cases. They give you a lot of flexibility, and I think that's our hot tip really for today. Let's dive back to the presentation and just take a look at what we've got in here. So we'd recommend you go and have a look at some of the companion webinars that we've put up in recent months. You can see there's a few of them. So if you go to our YouTube channel, so if you go to youtube.com/One Spatial Group, all one word, that's the number 1 at the front of that name, One Spatial Group, you'll see that there are 4 historic sessions that go through performance related things. I'd recommend you take a look at a couple of them for sure. They give you a lot of hot tips around how you can improve your processes, make them more performant. I'll leave those URLs up there for a few more seconds, but we will be publishing this webinar as well as a YouTube video at some point in the future, so you'll get to see it up there at some point soon. The other resources that we'd recommend you take a look at, obviously SAFE's website, and go to onespatial.com/FME for details of our capabilities around the FME product stack. The Knowledge Center is a enormous resource. You can post questions, you can create new ideas for things you'd like in FME, and you can also follow us on Twitter and take a look at both of the YouTube channels. We'd encourage you to go there. Other than that, we do a lot of FME training for our customers. Please go to our website, onespatial.com/events, and all of our public training courses are listed under the FME filter, so feel free to go and have a look at what we've got coming up. If you'd like us to come to you to do a bespoke training course or run one of our standard sessions in your offices, please also get in touch with us. We can work out a training schedule to suit your needs at a time that you need it from our certified trainers. For now though, thank you very much for listening, and I hope this session was useful for you. We will leave the session open for a few more minutes if you want to post any chat questions through to us, but for now, thank you very much for your time.